Hello and welcome back. My name is Steven, and once again I'm here to teach you more about C#, the .NET platform, and programming for Windows. In this episode, we're supposed to cover looping. We were supposed to cover looping last time, and I felt like the episodes were getting a little bit unwieldy. I think a half hour-ish is a solid amount of time to sit in on a lesson and learn about what this particular element has to offer. And I think for the most part, I'm going to try to follow that format moving forward. There are going to be some more complex topics that we get into, like database connections, calling SQL and MySQL databases, the syntax for those, and how you go and navigate through that data more specifically and more in depth. And those will warrant longer episodes, maybe 45 minutes to an hour. For the basic stuff, though, I think it's really important that we keep it to bite-sized pieces so that, like I said in the last episode, you can venture off on your own and play around with them. If you're running into red squiggles all over your code and you're having trouble, feel free to let me know in your comments, or in the comments, and I'd be happy to address whatever you've got. I can set up a web page or a Stack Overflow or something where you can send me some sort of code, and we'll figure out a way to talk through that. In this episode, we're going to start with our lovely little application. It's right where we left off with our list of groceries. I'm not actually going to delete this. I'm actually just going to bump down below, and we're going to start out with that for loop. This is my favorite loop in C# because the syntax, although not clear at first, allows you to be a lot more versatile. So what do I mean by that? What I mean by that is the for loop inherently embeds an index. Remember, we talked about arrays last week, and we talked about 0, 1, 2, 3, etc. for being able to insert or push things onto an array. Well, in a for loop, you can access that list item directly using the index. So I'm going to write out a for loop real quick. Just a real basic one that will declare an integer value of I. We're going to set it equal to 0. And as long as I is less than the list of groceries count, we're going to increment I. So I told you as well in the last episode that we would talk about plus plus and minus minus operators. Essentially, plus plus and minus minus, all they do is add or remove. They increment or decrement by a value or factor of 1. So if I were to if I start I on 0, as I'm doing here, and I increment it once, I will then equal 1. From there, if I increment again, I will equal 2. And if I increment again, I will equal 3, and so on and so forth. If I were to do minus minus, it would then be starting at 0, we would then move to -1, and then -2, and -3, and so on and so forth. This is infinitely capable upon the size of the integer being maxed out. If this is an int 16, an int 32, an int 64, etc., they have different sizes in memory that they can reach before memory can no longer handle them. In this case, we're going to count from 0 to 2 because it is less than the count of items, which will be 3, and no more than 2. So this is going to be the for loop declaring an integer of 0. That's our starting index, is 0. And as long as, this is our conditional, this is our if the value of I is less than 3 items in the list, less than the count of the items, we're going to increment I and do the loop again. So in this case, I can say list values dot add dot items dot add, and I'm going to say list groceries. I'm going to access that index again, only I'm going to pass in the value I. What this is going to do is on 0 of the for loop, the first time we go through it, I will equal 0, And list groceries, the index of list groceries that is 0 will output to our list. Let's run this real quick so that I can show you a little bit more accurately. And I'll put my breakpoint here. So we're in our form, and I'm going to, because we're in this event here, click our add value button. And we've got our list of groceries. We've added eggs and milk, and now bacon. So the total count of our grocery list should be 3, because we have 3 items entered into that list object. Here, the for loop enters in to declare I as a variable. So I is equal to 0 now. List groceries.count is 3, so 0 is less than 3. We're going to go into the logic of this loop. We're going to go into this block. And remember, I is 0. Remember back to our arrays. That's the 0 index. That's the first item in the list of items. So we're going to grab the item that is in the first index position of our list of items. In this case, it will be eggs. So I is 0. List groceries, you can hover over a list unless it's bound, and we'll get into binding later. Hover over our arrow and it will show you all the values and their indexes of the list in Visual Studio. In this case, 0 is eggs, 1 is milk, and 2 is bacon, because that's the order in which we added them up above in lines 24 through 27. So if I type out list groceries, open square bracket, 0, close square bracket, we're going to get eggs, because that's the value at the 0th position. And we're going to add that value to our list box in the front, to that list of items. So I can do this, and I'm hitting F10 here. When you are debugging a program, in this case we hit a breakpoint, this red stop point, when we started our program and hit the button. It gets to this point and it pauses all of our functionality, lets us look at a bunch of variables that are in this context. We'll have an episode on debugging later. And I'm stepping through. That means going line by line and viewing what my program is doing. It's very simple in this case because we don't have a whole lot of code and we don't have multiple files in play or anything like that. But the concept is line by line. If there were another file we were accessing, this would attempt to go to that file and show me what's going on in another class and method and so on and so forth. Complicated, like I said, we'll get into debug stuff and complex solutions later. But for now, what you need to know is I'm stepping through line by line what our program is doing. And the shortcut for that again is F10. So if you don't see me hit this button, it can be found here, this step over. And we'll get into step intos and step out ofs and things like that when we get into debugging. For now, it's important that you know step over, because we're going to step over. We're not going to get into how it's added to the list or anything like that. We're just going to say it is added to the list. And we're going to hit F10, and that will take us to our next line of code. Now notice where our code is highlighted. It's on that I incrementer, that I++ syntax. That's because in the for loop, we declare a variable. We check to see if the loop condition is met. In this case, list groceries.count is greater than the current value of I, or a more simple way to say it is I is less than the count of the list items. And then we go through the logic. In this case, list values.items.add list groceries, the value of list groceries at the index of, in this case, 0. And then we're going back up to the loop and incrementing I, that final statement at the top, I++. So right now, I is equal to 0, and when I hit F10, it'll show I is equal to 1. And we jump back to our conditional to make sure that our loop is still true, and we move forward again. We jump back into that. We don't have to declare int I every time because it's already a variable in our context, in our memory. don't have to worry about declaring that multiple times, but we always have to do something with I, and we always have to check if the loop is still relevant, if our data is still eligible to go through this logic. So now I is equal to 1. We want to add the value of list groceries at index 1 to our list item on the front end view. So take a second. What value is going to be returned from list groceries? It could be eggs, milk, or bacon. If you need to pause the video, please feel free to. But I'm going to give you a brief amount of time here, and then we're going to jump into the next line. All right. So here's the answer. In 3, 2, 1, it's going to be milk, because that is the value at the first index, which is the second item in the list groceries. List groceries, hover over. The value at 1 is milk. Pretty simple. That'll go into our list of items. You can hover over this list of items as well. You can see the count is 2. This doesn't give you the list items or the actual values in the list very easily. Don't worry about that so much. That's why binding exists, and we'll get into that down the line. For now, trust that milk has been added to our front end. So we're going to F10 again. We're going to increment I from 1 to 2. We're going to check to make sure that 2 is less than the count of our items, which in this case is 3. It should be less than that. Once again, we're adding the next value from our list to the front end, and that should be bacon. At value 2, because I is equal to 2, in the third position of the list, bacon. So now we're at the end of this for loop. We're going to increment I again, because we don't check first if it's valid. We just increment I. In this case, I is now equal to 3. Is 3 less than 3? No. 3 is equal to 3. And therefore, it will break out of the loop. This is a really rudimentary but fundamental and necessary loop. This is super versatile. It allows you to access linked items through multiple lists very easily, especially if you have trouble with multi-dimensional arrays when we get down the line to those and get into more complex objects instead of just primitives. Being able to access items in 2 separate lists from the same index can be very, very useful. If I were to say, make this a I is less than or equals to listgroceries.count, what would happen? Again, pause the video if you feel you need more time. What would happen here is if I were to set I less than or equal to the count of items in our grocery list, we would enter into the for loop a 4th time, a 3rd position time, or 4th position. Zero base gets confusing when you're trying to talk in English. I is, say, equal to 3 at this point. And since I is equal to, or since 3 is equal to 3, I is equal to the count of items we have in our list, we would enter into the loop. But list groceries doesn't have an index of 3. In fact, let me step through that real quick for you. I can show you exactly what happens. So I is equal to 0. I is equal to 1. I is equal to 2. And now I is equal to 3. We enter into the loop, just like I said. We get to this line, and again, I is 3, but list of groceries doesn't have an index value of 3. It has 0, 1, and 2, 3 items, but it doesn't have the 4th item, which would be index 3. This will result in what's known as an exception. More on that when we get into error handling, which will probably be the predecessor to the debugging episode, or possibly the follow-up to debugging. That might be a two-parter. But you'll get this exception, which is basically a fancy term for the code throws an error because it doesn't know what to do. It doesn't know how to handle the issue at hand. In this case, it will be what's known as an index out of bounds exception. An index out of bounds exception is essentially you are trying to access a member of this list, like eggs, milk, or bacon, but the index you've supplied, the I value you've supplied, doesn't exist in the array. It could be a -1, or in this case, it could be 3. Because the list only has 3 items in it, it doesn't have that 4th position of index 3. This isn't possible. There's no value there. It's dividing by 0, essentially. So when I step over this, we get this index was out of range, argument out of range exception, must be non-negative and less than the size of the collection parameter name index. Essentially, this says that the parameter name, the index, that's what we're passing in to grab the value out of our list, that I value, can't be negative. So it can't be -1, -2, -3. Work with absolute values. And it has to be less than the size of the collection. So it has to be less than the total count of items, because the count of items is going to be 1, 2, 3, 4, 5, 6, 7, so on. But you're going to iterate through when your count is greater than 0, because why would you iterate through a bunch of logic on a 0 value when there's nothing in the list? So we're going to need to keep it within the bounds. 0 index and the count -1. Off by 1 errors, once again, as I said in the last episode, are one of programmers' biggest issues. It's very difficult to remember off by 1 errors when you're working through data. And again, database access, more complicated classes, etc., etc. Insert this reminder there. We're not there yet. But this is important to remember that if you do less than or equals to, you have to make sure you do list groceries.count -1. Something like this. And I'll show you what the result of this is. It is easier to just do the less than symbol, by the way. For I is less than list groceries.count. Doing equals to doesn't make a whole lot of sense, but some people do it. I don't know why exactly, but if you do the -1 after the count of your list items or your collection, which is a fancy name for a list or array of items, then you should be able to avoid this error almost completely. So if I run this right now and I hit add value, we get eggs, milk, bacon in our front end. And that would be the same as if I remove this -1 and the equals sign from our for loop and I hit add value, eggs, milk, bacon. Because we're not any longer trying to access a value that doesn't exist in the list. That's a for loop. It's really basic. It's really straightforward. It's really simple. But it's not as simple as the other loops. I like to start out with this one because, again, it's the most transformable. It's the most permutable. It's the most useful loop that I've found. I prefer this over the while loop and the for each loop, although I use the for each loop quite a bit. The while loop I only use for data streams, reading and writing from files, etc. And it feels kind of gross to use. And that's not that it should for you. That's a personal preference. Find the loop that works for you and learn how to use that loop for every specific situation that you need to. And also don't be afraid to use different kinds of loops to access information differently. Next up, we're going to do the for each statement, which essentially says for each string, in this case I'm going to name that variable item in list groceries, list values dot items dot add item. So the difference between the for loop and the for each is the for loop assigns a integer value and accesses items in a collection via the index, that I value we declare. A for each statement assumes a data type, in this case string we've declared, and grabs that value from the items in the collection. Rather than giving it an index and going to that extra step, it just kind of cuts a couple of corners and allows us to access that value directly. It's a shorthand way of doing a for loop in this case, but it doesn't allow you to do much as far as cross-list referencing or index play or any kind of conditionals based on the count that we're in. In this case, the for each item is just going to return eggs, milk, and then bacon. And we'll step through this one because that's the easiest way to show it to you. We're still declaring this item, this variable item, but we jump to the list of groceries. And essentially what this is going to do in the back end is index them all of the items. It's going to grab the first item, and then the second item, and then the third item. Going through this logic each time is known as an iteration, and you've probably heard that term elsewhere. This is what's known as an iterative or an iterative process. I like to use the term iterative because it makes me sound smart, I think. I'm probably wrong there. But using an iterative, an iterative allows you to go through a collection and access an iterated item. So in this case, we can hover over our groceries. Maybe we don't know what index we're on, but we can hover over item and see, oh hey, the value, the string value is eggs. Knowing what I know here, we must be on the first iteration of our loop. So what am I going to add to my list of values on the front end? Eggs. And then the next one should be, say it with me, milk. Item, milk. And finally, bacon. And then we break out. If you want to continue execution of your program, by the way, this is handy to know. Say your cursor is highlighted here. Well, I can show you. Add. Say you've done all of your debugging, you've seen the values you want, you can break out, or you can prevent your breakpoint from getting hit again, and you can hit F5 to execute. This is essentially the same as hitting the continue button up here. If you don't have a debugging session started, you can actually hit F5 to start that program. So that's F5, and it just runs through the rest of the program, as long as there are no other breakpoints. But see, the for each just adds the value as a string rather than going through the index. This is a great one to start out with as an early programmer because it cuts a lot of corners for you. You don't have to know the syntax of a for loop, but again, it's not as versatile in my opinion. This can also be done with an integer. If you had a list of 0, 1, 2, 3, 4, or maybe doubles, you might have a list of account balances or a list of transactions from a bank account, and you would add those to a list of a list of doubles, and maybe add that to a list output. For instance, if I were to do this, EC, control EC is comment out each line individually. Not block comment, but inline comments. So if I were to have a list list double, let's do transactions. I have trouble naming my variables. I don't like commitment to variable names. So we'll do list double transactions equals new list double. By the way, when you're typing out equals new, IntelliSense will pop up this little tool window, this context menu. You can just hit enter on that and it will autofill your value. So now we're going to drop transactions in instead of list groceries, and we're going to do transactions dot add, and maybe this is I'm just going to do a couple of quick values. I'm trying to mimic some sort of money value, something along those lines. This for each statement needs to have an int, and you can rename this to transaction. If you hit Alt Enter when you've renamed something, so if I highlight item here and I rename it to transactions, or sorry, transaction, if I don't backspace on it, hit Alt Enter. Oh. Well, ignore that then. Usually it will go through and allow you to auto update your, or auto rename your variable, and it will automatically update all of the calls to that particular variable. In this case, it just goes to show, by the way, that I am not perfect at this stuff by any means. Even the basics of Visual Studio kind of elude me, and there are a lot of settings to play around with too. We're going to hit add value, and that's interesting. It cut off our double values. Why? Can anybody guess? It's because I typed in int here instead of double. Because I typoed and wasn't thinking. But notice it does chop off that 0 that we put here. If you want to retain that, this is something that you can do. This is what's known as a cast. We'll get into casts and things like that, explicit and implicit casting in its own episode. I'll say that a lot throughout the basics here, but you can do a .toString 0.00 as a string value as a parameter to the toString method, only for doubles and maybe longs, but that will retain that double decimal point for you. Decimal position is the word I was looking for. So you can do it either way. And I'll go through and I'll back out all these changes. And that's the for each loop. Really straightforward, really simple. It grabs the value at each index and returns it without having to deal with the index. Now, we're going to do a do while. Now, the do while statement is an interesting one, because essentially this is the sister loop or a reformatted loop to what is known as the while loop, or a while do if you come from the VB world. This is the unconventional one to start with between the two, because typically in C# you would just see a while loop. There's a distinct difference between the two. In this case, do is going to say, do this logic once, and then check to see if a condition is true. And if it is true, do this again. And then check again. And then do it again. And then check again and do it again. And as soon as this becomes false, then it will not go through that logic again, and it will move to the rest of your code. I don't particularly use do whiles that often. I just make sure that in my while loops it's executable at least once, or make sure that I don't need it at all. If there's not a value to iterate on, don't execute the logic that I've defined within the block. In order for me to make a simple loop of this, I can declare int I equals 0. And while I is less than the list of groceries.count, just like our for loop was, I'm going to do list values.items.add list groceries and grab our index item from there. This feels really familiar because it fits a very similar cause in this example to the for loop that I mentioned first. This is not nearly as clean. It feels really kind of clunky because we have to declare the variable outside of our loop. Then we have to dispose of it. We can't ever use the letter I for another loop in this case if we were to ever want to keep some sort of convention with that. But nonetheless, let's step through this. Again, it's not my favorite loop. It's a little bit messy for this particular instance. There are instances and arguments that I've seen made for it that have been very useful, especially in dynamic control generation or dynamic user interface generation. Again, say it with me. That's another episode. So we're going to hit add value, and you'll see, oh, and actually, this is a semantic issue. I forgot something in here. I forgot to increment I. That would have been an infinite loop, and it would have broken at some point. The C# and Visual Studio programs and compiler and program, respectively, will catch infinite loops at a certain point or a certain number of executions per second and say, hey, you might have an issue here. Stop the program. We're in a broken state. Fix this. In this case, we're going to hit add value. I is equal to 0. List values. We're going to grab our grocery item. In this case, it's going to be the grocery value or grocery item at value 0, which is our eggs. We're going to increment I. I is less than 1. Or sorry, I is 1, so it's less than 3. So that should add our groceries. Now I is 2. Right? Yeah, 2. So we're going to add our 2 value. And now we're at while. While is 3. We're going to break out of our loop. And from there, it should look the exact same. Great. Another way you could do this is remove the do and put while up top, just like that. And suddenly you have a while loop. This will not necessarily iterate through the list of items, because if this condition is not true, it won't execute this block whatsoever. It'll just go down here and do something else. If it is true, it'll iterate through until this becomes false. So we'll execute our code again, hit add value. We'll see I is equal to 0. I is 0. I is less than the count of our groceries again. We're going to increment once again all the way through. Get up here, the count is 3. I is now 3. We're going to break out of our loop. Just like the do while, the difference is the do while does the block first and then checks, whereas this checks first and then does the logic. It's an important distinction, especially if you don't ever want to enter the code, if you don't have a value in a list. Use a while loop for that, not a do while. And there is our successful list of items. Those are the four basic loops. There's one more that is frowned upon for most situations. And I believe the term for it is a pragma. I could be wrong on that. I've heard the term pragma, P-R-A-G-M-A, pragma before, and it's a little bit out there because it doesn't follow normal processing. It's pre-processing, so to speak. So, and it doesn't follow normal syntax for a loop. In this case, let's say loop start, colon. And here we're going to say, actually, let's do int I equals 0 up there. List groceries dot add or sorry, list values dot items dot add list groceries dot sorry, there we go. And you'll say, oh, okay, so this is just a label. It's not been referenced. And if I is less than the list of groceries dot count, we're going to go to loop start. This is a loop. It's a frowned upon loop. I'll be honest, I have no idea why it's a frowned upon loop. I know it's ugly. I know there are better design patterns that can fit this, but it does the job? Question mark? I guess. The only time I've ever really used this is if I am trying to validate user input for opening up a menu or another screen. If they close out of it prematurely, then I open a message box, which is that pop-up box, see if their response is an expected response, and if it is, then do this thing where I pop up another window. So the message box might ask you, you closed out of this without saving anything. Are you sure you want to, or do you want to reopen the settings window or something like that? And if they say no, then I fall through and probably shut down the program because it's probably for a database connection or something along those lines. In this case, this is really pointless and overblown. I'm sure there's some sort of system tax that you put into it for resources or performance. And watch it fail. Oh yeah, miserably. Oh, that would be why. I once again forgot my I incrementer. We would just put I++ outside of the loop. Because that, yeah. So what happened there was I misplaced my I incrementer. Because again, I don't use this loop for this kind of thing. But the I incrementer has to go outside of the check for if I is less than count. Otherwise, we can get our index all the way up to 3, or the count of our list item, and still enter that loop, that final time, making, in this case, I equal to 3, which is the same as the count of our groceries, where we don't have an index. And we are post-processing in that case. So after the check, we increment I, so we get it all the way back up. So we're already going to go to our loop start again. But we were incrementing I here. So, oh hey, I is 2, so it's less than the count, which would be 3. We're going to increment it, get it to 3, start our loop, and now our list is trying to access that out of bounds index. So that, I think, is the final one. This is a label loop, or a pragma loop, I've heard it called. Labels, or that term could be wrong, I'm not sure. But that's essentially looping. That's really all we're going to cover for this. I know I've been going for a little bit, and I've been prattling on a little bit, but this is pretty important stuff too. We're hinging on the conditionals we talked about. We're using primitives to make decisions, and we're adding values to a user interface and to the back end that allow you to manipulate data and provide an experience to the user. This is super important stuff because this is really the building blocks of everything you're going to do in code. From here, we can make complex programs, we can make complex data types, we can manipulate a user experience on the front end based on this. And I think the next episode, we're going to talk about debugging and error handling. One of the two. Probably debugging, because we can talk about exceptions. We can talk about the breakdown of why the program breaks in different situations. It's going to be a lot of fun to actually break our program and then cover how to fix that. I'm not going to be able to go into a ton of detail on fixing specific situations or problems that you may run into, but I can at least give you some building block tools for the basics of how to find errors and kind of how to interpret some of the issues you might run into. I'll also show you a resource or two that I use personally that allows me to find out more about my issues that I'm having in my program. From there, we can get into handling the errors if we have enough time in the episode, which I doubt we will. And then the following episode will likely be on error handling, which will be try catches and catching data, bad data, before it jumps into our user interfaces and things like that, before it gets logic executed against it. Those two are going to be pretty pivotal episodes as well. A lot of these foundational episodes are going to be pivotal for your success in C# moving forward. This is really important stuff because it is the building blocks, but it's also where your mind is forming how to do the logic in C# itself. Whether you're a programmer from Java, VB, COBOL, etc., or you're somebody that's new to the programming world altogether. Either way, I encourage you to stick with it and keep working on it. Leave comments below if you have questions or if you have needs. If you have suggestions, I'm more than willing to take you up on whatever you may need or want to see in these episodes. If you'd like to see another series go up, let me know. I'd love to take a look at some Python or some VB.net if you find that your company or you are looking at using that. If you're looking at another skill set or something related to computers, I'm happy to consider it. I'm really trying to keep it pretty low-key and based on digital things right now, but eventually we might branch out into some other world-focused things, like maybe how to write D&D campaigns or something crazy like that. Again, thanks for checking out the episode, and hang in there. C# is an easier language, but that doesn't mean that it is easy in and of itself. Programming is inherently difficult, and it's a skill set that I hope that everybody can come to appreciate at some point. Until next time, thanks. Take it easy.